All right, and finally, let's take a look at how to make predictions from a random sample. So we are going to look at the difference between numerical and categorical data first, right? When you think of the words numerical and categorical, you should be able to picture what their definitions are, right? Numerical is anything that can be represented by data, anything that has numbers in it. Whereas categorical would be something that you cannot place a number on. For example, eye color, right? Can you say eye color is a number? No, it's a category. We have brown eyes, we have blue eyes, we have green eyes. Those are different categories. So your example, eye color for categorical, right? Um, Here we have students coming in from all over the area, right? So maybe neighborhood. What neighborhood are you from? Favorite color, right? We can't measure favorite color. That would be a category. What we can measure are statistics such as height. How tall are you? Weight. Salary, right? How much does each people make? That would be an example of numerical. Now, the appropriate statistics. In order to measure numerical data, we use the mean. Mean is the most appropriate statistical measure for anything numerical. As opposed to categorical, we use proportion. Okay, a proportion is what we use to compare categorical data. And when we talk about proportion, well, what is a proportion? A proportion is a relative frequency of a category. Relative frequency of a category. Make sure you have all of these definitions down. You do need to know these definitions. All right, so let's go ahead and look at this example. It says a community health center surveyed a small random sample of adults in the community about their exercise habits. The survey asked whether a person engages in regular cardio, such as running, walking, swimming, and if so, what the duration and frequency of exercise are. How long do they exercise? Of the 25 people surveyed, 10 said that they do engage in regular cardio exercise, and the table lists the data for those 10 people. Calculate statistics to make predictions about the exercise habits of the approximately 5,000 adults living in the community. All right, so as you can see in the table, 10 people said they enjoyed these types of exercises for this amount of time and this number of times per week. For example, this person likes to run for an average of 1 hour, 6 days a week. This person likes to walk 20 minutes for 5 days a week. Okay, so let's go ahead and use that data to calculate different proportions or different statistics. For example, A, it says calculate the proportion of adults who get regular cardio exercise. Well, based on the data here, we know that we surveyed 25 people and 10 said that they engage in regular cardio exercise. So that means we have 10 people engaging in cardio exercise out of the 25 people surveyed. So if we simplify this, we can simplify down to 2/5, which is the same as 0.4. Turning it into a percentage, we know that 40% of adults get regular cardio exercise. Pretty simple, right? Example B says calculate the proportion of runners among adults who get regular cardio exercise. So this time we're only looking at runners based on those who get exercise. So how many runners do we have? We have 1, 2, 3, 4, 5. 5 runners out of how many? Out of 10, right? Because 10 get regular cardio exercise, gives us a proportion of 1/2, which we know is 0.5 or 50%. This tells me 50% of adults who get regular exercise are runners. Example C, use this proportion to predict the number of runners among all adults living in the community. Okay, so this is where we have to consider these statistics up here. It says the community is made up of approximately 5,000 adults. So we're going to take that number and we're going to multiply it by the proportion of adults who get regular exercise. So that would be 0.4. Okay, so first of all, out of those 5,000 adults, how many of them get regular exercise? That's 2,000. 2,000 adults get regular exercise. And out of those 2,000 adults, how many of them are runners? Well, we know that half of the population, according to our survey, 50% of that population would be runners. So if we multiply 2,000 by 0.5, we get 1,000, which tells us that 1,000 adults are runners in this community. Okay. And finally, for example D, calculate the mean duration of exercise and the mean frequency of exercise for those who get regular exercise. Use the means to predict for those who get regular exercise the number of hours spent exercising each week. All right, so we're going to look at these calculations. And we're going to determine how, first of all, the mean frequency of exercise for those who do get regular exercise. Okay, so what does that mean? It means we're going to take up the durations here and we are going to find the mean. So go ahead and add up. And you should have 480. And because we surveyed 10 people, that means that the average is 48 minutes. Okay, that's the first part. Second part, we are calculating the frequency of exercise. So how many times a week do they exercise? Well, now we're looking at this column here. Go ahead and add those up. And we get 37 divided by 10 gives us 3.7 times per week. Okay, now using this, it says use the means to predict for those who get regular exercise the number of hours spent exercising each week. So follow along, I'm going to do this over here on the side. Okay, that means if we are exercising, or these adults are exercising 48 minutes on average, times 3.7 times a week, they are exercising for an average of 177.6 minutes per week. It asks us to determine how many hours, so we have to convert. Remember, there are 60 minutes in an hour, so I'm going to divide by 60, giving us an average of 2.96. Now, when we talk about time, we don't say, I exercise for 2.96 hours a day, right? We would round this up and say that they exercise for an average of 3 hours a day, or sorry, per week. Okay. All right, go ahead and hit the pause button once again, and go ahead and try example 3, and then come back and check your answers. All right, if you did the work correctly, for A, it said find the mean of the days skied. So that means we would look at the number of days, and it is split up into 2 columns here. Okay, so we would look at this first row and the second row, add them all together, divide by 16, and you would get a total of 12.125. Of course, rounded down, that means we are looking at a mean of 12 days. For part B, find the mean number of lift rides taken per day, add the bottom rows here, and divide by 16 once again, and you should have 11.625, which again gives us a mean of 12 rides per day. And for C, use the means to predict the number of Lyft rides taken per season per pass holder, which means we would simply multiply and get our total of 144 Lyft rides per season by a pass holder.